We're going to look at 5.4 complex numbers now. Complex numbers are a combination of imaginary and real numbers that are put together, and you're dealing with radicals as well. The big thing is a pure imaginary unit is a term with an I. Okay, it has an I next to it, and it's just one term. Um, Now, the pure imaginary numbers are pretty much the same thing. Okay, they are a term that has an I next to it. An imaginary unit is the term with an I in the complex number. So if you have 2 plus 3i, the imaginary unit would be the 3i. The pure imaginary numbers is just the 3i. Okay, so it's just one term, it's only imaginary, it doesn't have this real portion right here like that one does in complex numbers. So the first thing we're going to talk about is simplifying radicals. With radicals, obviously we can't have a negative underneath the square root. Think about it. What two numbers multiply by themselves to give you a negative? It doesn't happen, right? Because two positive is make a positive, two negatives make a positive as well. So because of that, what you do is you take out essentially the square root of negative 1, okay? The square root of negative 1 is what the imaginary unit is. That becomes I, and that's every time. Okay, so anytime there's a negative, you can pop an I out, and then it becomes a positive. And then we break it down like we normally do, right? 27 is 9 times 3, 9 is 3 times 3. And this is where we circle our pairs. So we have a pair of threes, so that goes on the outside. The I is on the outside, but then we have a lonely 3 on the inside. So the same thing is happening for 2, 3, and 4. Number 2, there's a negative underneath the square root, so I'm going to pop an I out. So now we have 28. 28 is 7 times 4, and 4 is 2 times 2. At this point, we have a pair of 2's on the outside, your I, and then a lonely 7. Go ahead and try the next two on your own before you watch me do it. At this point, hopefully you had enough time to do those. If you haven't, make sure you pause the video. But on number 3, we pop an I out, you're left with the square root of 32. 32 is 8 times 4, 8 is 4 times 2, 4 is 2 times 2, and then we have another 4, which is 2 times 2. Sorry. So we have a pair of 2's and another pair of 2's, which makes 4 on the outside, along with our I, and then a lonely 2 on the inside. Remember, when there's two numbers or more on the outside, you multiply them. If same thing on the inside. If anything's left over, we multiply them. On number 4, pop an I out, you're left with 125, which is 25 times 5, and 25 is 5 times 5. So you're left with a pair of 5's on the outside, an I, and a lonely 5 on the inside. Now, because I is represented as the square root of -1, you can take it a little further to figure out what I squared, I to the third, I to the fourth, and so on are. Okay. Really, you don't have to memorize any of these except for the first two. Okay. If you have I squared, or sorry, I is just I, right? It is the square root of -1. Okay. But if you get I squared, it would be a -1. Okay, if you think about it, if you square the square root of -1, you'd get -1 because it would cancel, right? So those are the main two to focus on. After that, you can just put them in combinations of I squared and I, which give you one of those answers. Okay, so it's either going to be I, -1, negative I, or 1. Anyway, working with these two, you can multiply imaginary units and you can multiply radicals, right? So looking at number 5, I have -5i times -3i. So think about it, -5 times -3 is 15, and I times I is I squared. At this point, I know what I squared is. I squared is -1. So it's really 15 times -1, which is -15. On our next one, I would multiply the radicals first. So we have the square root of 90. Now we have 9 times 10, 3 times 3, 5 times 2. If we rewrite this, we have 3 and then 5 and 2 on the inside. Notice how I did not have an I. That's because there is not a negative underneath the square root here, so we can leave it just like this. On the next one, we have 3i times 4i, so 12, and then I squared. And I squared we know is negative 1. So in reality, we have negative 12. And on our last one, multiply them, and we get the square root of, well, actually, let's look at it a different way. Okay, when you do this, you can break it down as 20 and 12 instead of multiplying them first. So let's look at 20. 20 is 4 times 5, and 4 is 2 times 2. Now I can keep working with this and break down 12 and then find my pairs. So 12 is 4 times 3, and 4 is 2 times 2. So if I want to rewrite this, I have 2 pairs of 2's, which make a 4 on the outside, and then a 5 and a 3 on the inside for 15. Okay, notice how the negatives go away because a negative times a negative is a positive, so it doesn't really, it kind of means like it's not there. Okay, you don't have to do it that way. You could do it more like number 6, but it's just a different way of looking at it. The next part we're going to talk about is solving. Okay, so when we're solving equations, this is very similar to what we've done before. We would subtract 256. So we have 4x squared equals negative 256. Divide by 4. So x squared equals negative 64. Now when we square root both sides, we notice that it is a negative 64. So remember, when it's a negative, we need to pop an I out. And then we have the square root of 64, which is 8. So we have 8i. The big thing with this part is that you're always going to have a plus or minus, because that could be a positive 8 or a negative 8. Okay, so we need plus or minus every time we take the square root. So on number 10, we would subtract 4, and you're left with x squared equals negative 4. And when you take the square root, well, the square root of 4 is 2, but we have a negative, so we had to pop an I out, and we need the plus or minus. Now, these are not always going to give us good answers. They might give us something like the square root of 90, right? And if that's the case, you do need to break it down so that it's something like this, plus or minus 3 root 10. Okay, so keep that in mind. The last thing we're going to talk about today are just complex numbers in general. Complex numbers are a combination of a real number and a pure imaginary number. These terms are not like terms and cannot be combined. Okay, it's represented as a plus bi. So if we look at number 11, we are adding these two complex numbers, right? So all we're doing is we're going to look at the real numbers first. So we have 5 and then 2. Notice how there's a plus in between it. So that means it's 5 plus 2, which is 7. At this point, we can look at our imaginary numbers, right? We have a negative 7i plus a positive 4i. So negative 7 plus 4 is negative 3i. And we cannot combine these. It's just like as if we had 7 minus 3x. We wouldn't do anything with the 7 or the 3. On number 12, very similar. But whenever you have a minus in between, I encourage you to change it to a plus sign. But if you do that, that means that you're distributing the negative. So you need to change everything after it. Okay, and this is how I do it. I just write it over it. The reason why I do that is because it's easier to think about it as a plus. If you want to use it as a minus, that's fine. It's just people often forget that it's a subtraction if they don't distribute. So I'll combine the real numbers. 4 plus a positive 1 is 5. And then positive 6i minus 2i gives me a positive 4i. And again, I can't combine those.